Hi, this is Natasha Masando, and today I'm going to be discussing the topic hierarchical agglomerative clustering. And today we're going to be looking at this data set with our given items here and our given clusters from P1 to P5 and then P1 to P5 here are the item sets. So hierarchical agglomerative clustering is formerly known as HAC, which is for data warehousing and data mining. It starts with one cluster, individual item in its own cluster. For example, like here is one cluster. And then it relatively merges clusters until the items belong to just one big cluster. So the really main points to think when you work with this type of algorithm clustering is that you also have to make sure you follow and merge classes together, and then they're particularly used to represent the HAC. So HAC uses three methods. It uses like the single nearest points or distance or single linkage. It completes furthest distance or complete linkage, and then it does the average distance or average linkage. So when we go down here, we can see that we have what we call a dendrogram. So a dendrogram is like a tree structure which represents hierarchical techniques. So we have the leaf nodes, which are here at the bottom, and then the leaf nodes are the sides, and then these are like the roots. So for example, when we look at our dendrogram, we see that we have A and B, which forms one cluster because they're nearest together, and then we have C and D, which forms another cluster, and then we have A and F, which forms the main big cluster. So these would be the root items, these letters here, A, B, C, D, E, F, and then they form one big cluster altogether if we combine A through F. So we first need to, whenever you're working with this clustering, you would first need to plot a diagram or a graph to show your nearest points that are given. So we have 6 items, item sets given in 5 coordinates. So we have here 1, 2, 3, 4, 5, 6, and then 5 coordinates, right? And then we need to draw a graph of the points and then given our data set. And then we need to calculate the Euclidean distance for distance matrix. So this is the equation to calculate the distance using the Euclidean formula, which is the xy x squared parenthesis. So I did the first example using my given points here from my item sets that was given to me. So we did P1 and P2 distance. So this is P1 and P2. So pretty much we say 1.00 minus 0.10, and then 0.10 minus 1.00. So this is the mathematics that I did here. And then we got the value point 1.27. And then we bring that 1.27 here. And then we make sure that we do the same U distance matrix for each and one of every point that was given here. So after filling out my table, I now had to look for the minimum value. So if you look at my item set, the minimum value is 0.11, for example. And then what you do then is I did the second part, and then I got 0.22 using the same formula from above. And then I plotted the 0.22 as my new item set for P1 and for P2 and for P3 and P4. Apologize. So pretty much we use this to find the clusters by getting the minimum value between P3 and P6. So P6 here, P3 here and P6 right here, the minimum value is 0.11, right? And then we would need to update the distance matrix and then use those those minimum values from those two points, P3 and P6, to create a new cluster. So then we get a new value, which is 0.15 for P3 and P4. And then lastly, whenever we do the new update distance from the matrix, we get the new cluster P3, P6. So it's no longer just P3 because we've already combined the clusters together to form P3 and P6. And then the minimum value point in this new set is 0.13. And then as we look down here at our graph, we see that we have the points, the clusters, P3 and P6. And then that forms our first cluster. And then we have 5 and 2, which forms our second cluster. So we pretty much continue to update the distance matrix minimum and use these values for our new cluster until we form, like from our previous calculations, until we have a bigger cluster. So if we continue to calculate the P minimum value points, in the end we have like a bigger cluster that will go all the way around all these other clusters. And that's the end of my video. Thank you.